In this lesson, you will learn about scatter plots. Let's take a look at some notes, some vocabulary, and some examples to help you better understand this concept. Scatter plots. If you look at this box, it says, have you ever been curious to know if one event affects another event? For example, if I study longer, will I get a better grade on my Unit 6 exam? Well, what do you think? It seems logical that if you study longer, you will get a better grade on an exam. But is that always true? Not necessarily. So a scatter plot helps tell you a relationship between two things. So if you look at the first paragraph, it says, statisticians and quality control technicians gather data to determine blank between such events. There's a word we use to determine a relationship in a scatter plot, and that's called a correlation. So a correlation is a relationship between two events. Scatter plots will often show at a glance whether a relationship exists between two sets of data. So let's decide if studying longer will affect the Unit 6 exam grades based on a specific set of data. If you look at this table, it shows you the study hours for several students and then their Unit 6 exam score. And then those points, each one is actually an individual point, and those points were graphed on the scatter plot to the right, with hours of study along the x-axis and their score on the y-axis. So if you look at the pattern of those points, you want to look for the general direction that the points are going in. And we can draw a straight line through them called a best fitting line or line of best fit. And when you draw that line, you want it to go through the center of the points with some points above the line and some points below. So it might look something like this. So notice you have some points above and some points below the line. So if you look at this arrow or this line that we've drawn, the line is going up from left to right. When the line is going up, it has a positive slope. A positive slope in a scatter plot tells you there's a positive correlation between the scores and hours of study. A positive correlation means as one thing increases, so is the other. So in this case, as the hours of study increase, so do the scores. And this again would be in most cases. Let's take a look at the next example. In the box that's highlighted in yellow, there's a very important point to note about scatter plots. It says, just because this set of data showed a positive correlation does not mean that the relationship is positive for all sets of data concerning study time and Unit 6 exam scores. There may be sets of data that show that there is not a positive relationship between hours studying and better Unit 6 exam scores. It all depends on the data that's being examined. So this is just something to note. If you look below the box, it then states if the slope of a line had been negative, so if it had been falling from left to right, a negative correlation would exist. Since the slope of the line would be negative. Under a negative correlation, that would tell you that the longer I study, the worse grade I would get on the exam. This would not be a good thing and does not seem like a logical correlation. Let's move down below. If you look at this paragraph at the top, it says, if the plot on the graph is scattered in such a way that it does not approximate a line, that means it does not appear to rise or fall, then we say there is no correlation between these sets of data. This means that there is no relationship. So in this case with studying and grades, if the points were scattered and there was no line developing between those points or no correlation, that would mean that the amount that someone studies doesn't have any effect on their grade, which we know for the most part is not true. Now below on these graphs, it says check out these graphs for visual interpretations of different types of correlations. So if you look at the graph or scatter plot on the left, you will see these points are going in an upward direction from left to right. And notice the points are fairly close together. This is said to have a high positive correlation. In the graph next to it on the right, the points are fairly scattered, but you do see some that are heading in a general upward direction because you do see space down here and space up here. So when the points are heading in a particular direction, but they're very spread apart, we say it has a low positive correlation. Let's take a look at some more. On the flip side, if you look at the graph on the left, notice this time the points are going in a downward direction from left to right, and they are fairly close together. So this would be a high negative correlation because the slope is negative. In the graph to the right, the scatter plot shows, again, you can see some space below and some space above, so they are going in a downward direction, but are very scattered apart. So this would show a low negative correlation. Let's take a look at one more graph that shows no correlation. In this graph, notice the points are completely scattered. There is no space above or below going up or down, so you can't really draw a line of any sort. So in this particular example, whatever the data points would represent would show that there is no correlation between those data points. In this next example, this would show that correlation does not necessarily mean causation. So just because there's a strong correlation between the data does not necessarily mean that one set of data is causing the effect that is occurring in the other. So here's an example. If you look at this table, on the left it says the jars of strawberry jam sold in New York. And then on the right, the number of CDs sold in Florida. Now, do you really think that the number of jars sold in New York of jam really has anything to do with the number of CDs sold in Florida? Of course not. However, when you graph this, let's see what it looks like. When you look at this graph showing the number of CDs sold and the number of jars of jam sold, notice it appears to have a positive correlation. However, logic would tell you that it does not. So always be careful, as this last paragraph says here, what you infer from the statistical analysis. Be sure that the relationship makes sense. Also keep in mind that other factors may be involved in a cause and effect relationship. Now let's take a look at some vocabulary. Okay, so now that we've looked at the word correlation, what does correlation mean? Correlation simply means a relationship between two sets of data. A relationship between two sets of data. So if there's a positive slope, it has a positive correlation or a positive relationship, which means as one increases, so does the other. If it has a negative slope, it's showing a negative relationship, which means as one increases, the other is decreasing. So they're going in opposite directions. We also talked about the line of best fit. So a line of best fit is a line that best represents the data points. So it's a line that best represents the data points. So that's the line I drew right through the points, making sure it goes through the middle with some points above and some points below. And that line should be heading in the same direction as the points. The last vocabulary word is outliers. Sometimes you have a point that does not fit the data. So let's write that down, a point or more points that does not fit the data. So an example, if we think back to the studying for the exam and the grade, an example of an outlier would be if there was somebody who did not study at all, yet still got an A. They would be an outlier because they would be unique compared to most of the rest of the individuals. Another example of an outlier would be if a student studied a lot, but then scored very low. So this again would be an example of an outlier. It would be out of the norm of what typically happens. Okay, so let's move below to an example. In example A, we're going to find the equation of the line of best fit, and then we're going to describe the correlation. So in order to find an equation, we need a line. So remember, our line of best fit would go through the center of the points, and we want some points below and some points above that line. So it's right through the center, or as close as we can get it. Okay, now from this line, we're going to choose 2 points on the line. So you might want to choose, in this case, the y-intercept, maybe this point, so some points that are on the line. And we're going to use those points to find the slope. So doing rise over run like you've learned in a previous lesson, the rise is 1 and the run is -2. So our slope would be -1/2. The y-intercept, or B, is the point where the line is touching the y-axis, and this is your y-axis. So your line is touching the y-axis at -3. So like we did in the previous lesson, we're just going to simply plug in -1/2 for the M and -3 for the B. And we have our equation. Now when we describe our correlation, notice the line is going down from left to right. So it's a negative correlation, which shows as one thing increases, the other decreases. Let's take a look at the next example. In this example, it says to study the data showing the number of people in a family and number of cell phones in their family after surveying a class of 9 students. We will then use this information to make a scatter plot and then answer the questions below. So you will see, if you look at the graph, the size of the family is on the x-axis and the number of cell phones is on the y-axis. So looking over at the table, the size of the family would be the x and the number of telephones would be the y. So each of these represents an ordered pair that will go on the graph. So let's graph these 9 ordered pairs. The first one we'll graph is Sally's. She has a size of family which is 5 and the number of telephones is 4. So we will go to the x-axis at 5 and then go up the y-axis to 4 and put a point. We will continue to do this for the rest of the individuals who were surveyed. So Tim would be at 6, 4. John would be at 3, 3. Jeff would be at 2, 2. Nancy would be at 8, 7, which is way up here. Katie would be at 5, 6. Dylan would be at 6, 6. Taylor at 4, 4. And then Julia at 6, 8. Right here. Okay, then if you look down at question A, it first said plot the points and draw the best fitting line. So now we want to draw a best fitting line, and recall that means a line that goes through the center of the points heading in the same direction, and you want some points to be below the line and some to be above. So my best fitting line might look approximately like this, and each line might be slightly different because this is just an estimate. It's not an exact line. Question B says, describe the correlation in the data and be specific. Well, we can see that it has a positive correlation because the slope is positive, or the line is going up. What this means in this situation is that both are increasing when there's a positive correlation. That means as the size of the family increases, so does the number of cell phones. So when it says to be specific, that's what you'd want to say. That as the size of the family increases, the number of cell phones increase as well. Let's scroll down and look at the third question, or question C. In question C, it says to find the equation of the line of best fit. So to find the equation, we need two things. We need m, which is the slope, and we need b, which is the y-intercept. So if you look back at the line, let's start with the y-intercept. So look down at the bottom of the line right here. Approximately where is that line touching the y-axis? Now you can estimate. So if you came out to 0, that would be fine. If you came out to a half, that would be fine. Okay, we're going to go ahead and say we're going to estimate it and just put it at 0, which would be 0, 0 if we want to be specific on the y-intercept. For the slope, choose 2 points that are on the line. It does not have to be one of those red points. However, if the line goes through 2 or more red points, it's okay to use them. So I'll go ahead and identify 3 using the green marker. Now from there, we will do the rise over the run, which comes out to 1 over 1, which would be 1 for our slope. Now once you know the m and the b, you can simply plug that into y equals mx plus b to get your equation. So y equals 1x plus 0. Now in this equation, you do not need to write the 1 and you do not need to write the 0. So it looks like it's just simply y equals x that represents this situation. Now if you move up to question D, it says use the equation to find the number of telephones for a family of 12. Now recall that the number in the family is the x. So in our equation y equals x, if x is 12, what would y be? Well, it would also be 12 because in this particular equation it says that the y and the x are equal. In question E it says, were there any outliers in the data? Now recall an outlier is a point that doesn't fit the norm. So in this situation it might be something like if the size of the family were 1 and they had 15 cell phones, that would be very unlikely and out of the norm. Now that's not the case for this example. On the other hand, another outlier might be a family of 5 that only has 1 cell phone, which is also not an example in this situation. So in this example, there were actually no outliers. And this completes the lesson on scatter plots.